So the other kind of challenge, I don't know how much time I have, Stefan. So other kind of challenge we have is what we call the multidimensional of our data. So we talk about 170 million records of primary data, but that's also we have around 2 million species. So if you start thinking about it really becomes complicated when you're going to create an interface to display it like this. So if you're going to set up something like a WMS server, what you're going to do? Have 2 million layers, one per species? That doesn't work very well with the OGC kind of layer world. I mean, we are not a layer kind of, we cannot provide a layer list. We are a kind of a data store. So, and when you actually want to do things like in Google, where they pre-process all those tiles, you just start getting into real issues. It's, if you have one layer like we've been showing, you can case it, very nice, that's fine. But if you have 2 million layers, then you start having billions and billions of tiles, and there's no file system that can support it, or you will pay millions and millions to Amazon for hosting it. So then you have to start finding different solutions. And I don't know if it's okay. Here is a demo about how it works. So the solution we have to came is actually we are on this tool that is the one that you can see in Encyclopedia of Life. Well, we went through multiple phases. On the first one were much simpler, but now it's like we only case up to a certain zoom level. That's because to avoid much heating on the servers, that's fine. That's not much data that we have to handle. And after a certain zoom level, we have to do it dynamically. There's no other way. And when we do it dynamically, there's relational databases, again, doesn't work. It's too much for them. You cannot keep them in memory so they don't become fast. And especially because Google is so fast serving their tiles, if you don't serve enough fast, it all looks awful. So then we started working with HBase and things like that. So trying to keep all these things in memory, pre-processing the data. So that's also things that we're doing right now. So a very big challenge, very nice challenge. I couldn't attend today the presentation, but there's other challenge that I like a lot, and it's related to cluster. It's a tool developed by Flickr. I don't know if you hear the developer. Oh. Thanks. So we took this open source tool from Flickr. That it's a tool for creating polygons out of points. So it really helped. It was fitting very well with our idea. So they're doing it with images and locations. So we're doing it with primary data and scientific names. So it's basically the same thing, but applied to our domain. So I think I have here, it's a video. So what we did is was analyzing the data that is within the GBIF network for a species called the European starling. European starling is an invasive species, a very curious story. It's not native here in America. It's native from Europe and Asia, and it was introduced at the beginning of the century by a person that decided that he wanted all the birds on the Shakespeare literature to be occurring on the States. So he came with 60 birds from England and released them in Central Park, and since then we started having European starling around, but it's actually very bad because it's an invasive species that is taking the place from other native birds, so it's pretty bad. So what we did here was with the points, technically, it was taking the data that we have on different decades and regenerating the polygons out of them. So you can see how actually, it's finished. But you can see how actually the information is showing the pattern of the starling spreading all around the United States and Canada. It's not so much in South America. So it was a very nice challenge, a very nice tool. Okay. Okay, perfect. So I think it's the latest. I get a bonus if we have time, but so another project we've been working on is a project between GBIF and the Convention of Migratory Species from IUCN. So they have this database called the Global Registry of Migratory Species. That's also another big challenge on this community, is that it's not we don't have only primary data. We don't have only points. We also have polygons. So we have experts saying like, well, I didn't check all around, but I can very fairly say that it's around in this polygon. You can find this species, and this is what we call authoritative range maps. So someone that is supposedly an expert is telling you should find it around here. So we're starting to think about how we can integrate all this information together to at the end answer the most fundamental question is where species are. So this is the project. This is still not released. It's a project developed, as I said, by GBIF together with the Convention of Migratory Species, and it's going to be available, I hope, soon in the next month. So what we are doing here is actually browsing the taxonomy of this global registry. It's only about something like 3,000 species that we have. So you can search, we have common names. So when you have 3,000 species, for us, it's like very nice because it's very little, it's very easy to handle. You don't have to get into very complicated things. So here's, for example, the blue whale. And this is the range maps described within this project. But again, one of the things that we have to do in this project that was also very, very cool was if you wanna map on the same map the different species, like this one, you see the pink one, the whale is pink, but this bird is red. So the thing is, like we cannot. It was very hard to actually generate these tiles dynamically. So we are casing them. But because we are casing them depending on how many species you are visualizing at the same time, you have to change the colors to make a legend. So this thing we also have to colorize the tiles on the client directly, depending on what he's visualizing. So it's another example of things. So here is 3. So the third one is colored in green. And we're working now more and more on integrating all this information from different sources. So you can have these range maps like polygons like this one, but you can also have it as grid maps. So there's like the flora of the Atlas of Flora Europaea. What they do is like they divide Europe in a grid, and they say, well, this species within these cells. Okay, so we have to integrate all this information together to be able at the end to provide an API, like I was saying, like what species are at this point, or where can I find this species. So this is a big challenge too that we're heading. So summarizing, yes, so finishing. I think biodiversity really matters, or at least I really believe in it, and I think we should really do research on it, and I think it's going to be a fundamental part of the Geoweb, hopefully. The other thing I want to bring here is that biodiversity informatics, this field, is all about open data. So it's all about the GeoWeb. So we are all about, putting it here and letting people experiment, do research with them, and I think it's very cool. And yeah, finally, if you wanna check it out, just join us, make use of the services, or help us to find out where species are. That's it. Thank you very much.
We've got time for several questions.
Maybe then I can actually add something more. I had a bonus. It was funny. It's today we've been working. I've been working for the last months with Google on a new API. It's called Google Maps for Flash. Well, it's already existing, but the new version that has some 3D. It just appeared. They've been working on the last months, and today it was actually released something like 2 hours ago. And so I asked them, and they allowed me to do some demos of it. So I'm maybe going to be the first one presenting this new API. That's very cool. It's the same map you've seen for Encyclopedia of Life. Actually, here we're visualizing all the data we have for Animalia. And the interesting thing about it is, like, this is the regular Google Maps thing that you can see. But with this one, you can start doing things like that. I don't know. I find it very, 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 very nice. I mean, the potential of this is like we can start like doing things on the web. I mean, because this is the web, this is Flash. So we can start like if we have multiple layers, we can separate them dynamically. So if you are visualizing them, I can separate them, visualize them different, then merge them together. So it's bringing the 3D finally to Google Maps on the web and not in Google Earth. And no Google Earth plugin needed. So. That's the only thing.